Okay, question number 1. So we have f of x equal x plus 1 over x plus 5. What is here? Vertical asymptote. Vertical asymptote is the value of x. It's an equation of x where denominator becomes 0. So here if we write down x plus 5 is equal 0, x is equal negative 5, which means x is equal negative 5. It's going to be our vertical asymptote. Number 2. So how will look, let's say, let me see, if I have f of x is equal 1 over x squared plus 2. How much is vertical asymptote here? There is no vertical asymptote because this denominator will never become 0. Even if you put negative 2, x is equal negative 2, because you have squares, so negative 2 always become 4, and plus 2 is 6, so there is no vertical asymptote. Number 3. So if x varies directly as y, x varies directly as y, okay, and x is equal 21 when y is equal 7. So find the x when y is equal 9. So x for y is equal 9. Okay, so we need to find from here first x, right? Let me write down 21 is equal 7k. So we need to divide by 7. This is gone. This will gonna be 3. So k is equal 3. And y is equal 9, right? K is equal 3. So using this directly proportional formula, we will have x is equal 3 times 9, which is 27. Question number 4. Suppose r varies directly as a square of m. So square of m. And inversely as s and s. So k m squared over s. Okay, so r is equal 20, m is equal 8, and s is equal 4. So we need to find r for m is equal 24 and s is equal 4. Okay, so for r is equal k times m squared over s. So we need to find k, because look, we are given m, we are given s. So to find r, we need to find out k, right? That's all we need. Okay. So to find k, well, let's plug r is equal 20, k times m is 8, which is going to be 8 squared, over s, which is 4. So 20 is equal 64k over 4. So 64 by 4, this is 1. This is going to be 16, right? So we are getting 20 is equal 16k. And from here, we divide by 16, and we divide by 16. And 16 is gone with 16. 20 and 16 we can reduce by 4. This is 5, this is 4. So k is equal 5/4. Okay, now let's find r for m is equal 24 and s is equal 4. So r is going to be equal k is 5 over 4. So it's going to be here m squared. I'm using this formula. M squared, m is 24. Oops. Which is going to be 24 squared. I'm just put 24 times 24. I don't feel like squaring. Just put easy way and divide it by 4. Right? Which is s. Okay, so this 4 with this 24, it's going to be 6. This 4 with this 24, it's going to be 6. So we are getting 5 times 6 times 6. 5 times 6, 30. 30 times 6 is 180. Okay. So, question number 5. We are given the graph of the function. So we need to know if this is 1 to 1. To find out if this is 1 to 1, we provide horizontal line, right? It's crossing only in 1 point, not in 2. Therefore, we get yes, 1 to 1. Number 6. So now algebraically we can figure out if this is 1 to 1 or not. 3 times x plus 1 squared minus 6. Look here, it's x, if I open this parenthesis, x plus 1 squared, I'm going to get x squared, right? Therefore, every time when you have x squared, excuse me, then there is no 1 to 1, because for the two different x's are going to have same y. Therefore, this is not 1 to 1. Number 7. So we have f of x is equal 5 to power x. And we need to find f of 2. And we need to find f of negative 2. Okay, very easy. So f of 2, just plugging 5 to power 2, 25. F of negative 2, we are plugging 5 to power negative 2. It's going to be 1 over 25, right? Remember, it's negative the exponent, and then you're going to flip the exponent. Flip the fraction. Number 8. So g of x is equal 1 over 2 to power x. So we need to find g of negative 1. It's going to be 1 over 2 to power negative 1, because it's negative. I'm flipping 2 over 1, which is equal to. Number 9. So we need to graph f of x is equal 2 to power x plus 1. Okay, so I'm taking x is equal, let's say 0. Then I'm getting 2 to power 0 plus 1. That is going to be equal to 2 to power 1, which is 2. Next. What's the other value? I'm taking x is equal 1. Oops. Then it's going to be 2 to power 1 plus 1. So it's going to be 2 to power 2, which is 4. And lastly, I'm taking negative 1. 2 to power negative 1 plus 1. 2 to power 0, which is equal 1. Okay, so 0, f of x is 2. This is 1 and... Okay, let me put this is 2. X is 0, y is 2. This is 1 point. Next, x is 1, which is going to be 1. Y is 4. 2, 3, 4. This is second point. And x is negative 1. Y is equal positive 1. So the graph, it's going to look like well, it's not crossing x, it's just going very, very close. Okay, because x is an asymptote. Okay, next what we need to find out, the domain. Well, there is no interruption, domain negative infinity, positive infinity, but for range, it's starting from where? X is equal, from which value it's starting? When x is equal 0, right? Or y is equal 0, rather saying. From 0, and it's going all the way to positive infinity because graph is growing. Number 10. Graph the function f of x is equal 8 to power negative x. Okay, real quick. So, two ways. Once we build f of 8 to power x and then flip it, or 8 to power negative x is 1 over 8 to power x. Yes? So let me go this way. So here is x, here is f of x, or 1 over 8 to power x. Okay, let's take x is equal 0. So 1 over 8 to power 0 is equal 1. X is equal 1. So 1 over 8 to power 1, it's going to be 1 over 8. And x is equal negative 1. 1 over 8 to power negative 1, we're going to flip it, it's going to be 8 over 1, which is going to be a positive 8. All right, so let me see. Okay, x is 0, y is 1. This is 1 point. X is 1. This is our 1, and y is 1 and 1/8, which is going to come here. and x is -1. So 1, 2, 3, 4, 5, 6, 7, 8. It's going right here. Okay, so the graph is going to go like this. Okay, and obviously domain is -infinity to +infinity, and range is going to be starting from 0, right? From this 0, because this graph is running to 0, so it's going to be from 0 to +infinity. Number 11, we need to graph 2 to f of x is equal 2 to power x minus 1 plus 2. Okay, since MyMathLab gives you ability to plug the shifting, so we have horizontal shifting. Horizontal shift, it's going to be +1, right? Because opposite direction, x minus 1, that means +1. Vertical shift, it's going to be +2. Once you plug it there, it will build you the graph, which will look like, here I'm going just to sketch, but there on the MyMathLab it will draw for you. Base is given, it will be taking automatically the base, these two, and then you just add that shift and vertical shift, which as I showed you on the recorded video, and you can use it. So, and it's gonna go something like this. Okay. Okay. So, and this point is gonna be somewhere 2 and something. When x is equals 0, so 2 and 1 half. Let me see. 0 minus 1, this is what I'm calculating. If x is 0, 0 minus 1 is -1. 2 to -1 is going to be 1/2 because we flip it. 2 and 1/2. So this point is going to be 2 and 1/2. Yeah. Okay. And the domain is going to be the same. -infinity, +infinity, because it's uninterrupted. And range, because it's running to 0, right? The graph. See, it's running to 0. Then it's gonna from 0 to in +infinity, because it's growing, the graph. Number 12. Oh, okay. Hold on, we have here shifting 2. 1 second. We have here shifting 2. So let me fix it. I forgot. 1 second, I'll let you know. So this is yeah, this is going to be your x, that is true. But the graph is gonna go, let me help the graph to build proper way. This is 2.5. Then graph is gonna go like this. So which means it's gonna run to x is equal to, this is 0, this is 2. This piece is 2 and 1 over 2. So this is how graph is gonna look like. Why is it 2? Because of it's shifted by 2. So instead of running to 0, it's gonna run to 2. Because this 0 moving to this 2, okay? That's why. Okay, question number 12. So, therefore here, instead of 0 to infinity, it's going to start from 2 to infinity, right? Because it's here, it's running to 0. So this asymptote x is equal to. Therefore, it's going to run from 2 to 0. Okay, question number 12. We need to graph f of x is equal to 2 power x plus 1 minus 4. Okay. So what we have, horizontal shifting, it's going to be -1. Vertical shifting, it's going to be -4. Yes. So when x is equal 0, with 2 to power, we get 2 to power 0 plus 1, x is equal 0. 2 to power 0 plus 1 minus 4. It's going to be 2 minus 4 is equal -2. So if we consider this as a -2, then it's going to go as a, and okay, let me see, it's going to cross this point also. Where it's going to cross it? Well, once you plug this vertical shifting, horizontal shifting, it will build for you. And I'm just going to show you how it's going to look like. Something like that. Okay, this is how it's gonna look, your graph. Okay, so vertical shifting is gonna be -infinity. I mean domain, -infinity, +infinity. Range is gonna be from -4 to +infinity, because we have here -4. And once I move this asymptote, it's going to go to -4. This point is going to be -4 because it's shifting to -4. Okay? Number 13. Solve equation e to power 11x minus 1 is equal e to power 9 to power x. Okay, so what do we have? E to power 11x minus 1 is equal e to power 9x, right? We multiply. Since base is the same, we can drop e, and we have 11x minus 1 is equal 9x. Moving 9x here, so we get 11x minus 9x is equal +1. 1 we move here, we get positive. So 2x is equal 1, x is equal 1/2. Number 14. (256 to power 4x is equal 64 to power x plus 2. Okay, so 64 is 4 to power 3. Power x plus 2. Now, since 256 is a big number and you don't know what base you're gonna take, you look here. Here you have base 4. Now try to get base 4. So to get base 4, what you wanna do? You wanna take radical degree 4 from 256. Okay? And let me see how much it's gonna be. I'm going to open, I think it's 6. We'll see. 256 and radical 4. 4. Okay, I thought 6. Never mind, it's 4. So it's gonna be 4 to power 4. To power 4x. Okay, so we get 4 to power 4 times 4x, it's going to be 16x. And here we get 4 to power 3 times x, it's going to be 3x. 3 times 2, it's going to be plus 6. So we drop this 4. Okay. Let me move it this way. Oops, 4x is not seen. Let me make it more visible. Okay. So we can write down here that 16x is equal 3x plus 6, correct? Moving 3x on this side will be minus 16x minus 3x is equal 6. 13x is equal 6. Dividing 13, dividing by 13, and we are getting x is equal 6 over 13. Number 15 question. So solve the equation for x. Log 25 by base x is equal negative 2. Well, okay, remember we go how? Base is x to power negative 2 is equal 25. So x to power negative 2 is equal 25. Okay, so x to power negative 2, we are getting 5 to power 2, right? All right, so, all right, I have base 1 is base is x, another base is 5. So one exponent is negative 2, another exponent positive 2. Now, can I convert the positive 2 exponent into negative 2 exponent? Of course I can. So it's going to be x to power negative 2 is equal 1 over 5 to power negative 2. Okay, and from here, since exponents are the same, then bases also can be equal. X is equal 1/5. Number 16. Log, we need to solve it. X plus 5. 1/2 is a base is equal to negative 4. Okay, I'm reading this. 1/2 to power negative 4 is equal x plus 5. Okay, so negative 4, if I flip fraction, it will 2 to power positive 4, right? And is equal x plus 5. 2 to power 4, it's going to be 16. 16 is equal x plus 5. Moving 5 on this side, both positive becomes negative. So x is equal 11. Log 13 by base x plus 4 is equal 1. So what do we have? X plus 4 to power 1 is equal 13, right? So from here, x is equal 13 minus 4. So x is equal 9. How it's gonna look, the graph of log x by base 3. So on MyMathLab, all you have to do, take correct graph tool for a login function, and I showed you how to choose the right one. At the bottom you can read if it's a login function or exponential function, and the graph will look like this. This is going to be 1, because when y is equal 0, x is equal 1. So 3 to power 0, it's going to be equal 1. And the graph is going to go like this. Okay? Next one, number 19. So using property to open up logarithm 8y over z, that is going to be equal, if I simplify, so between 8 and y is multiplication, which is going to be log 8 times log y, plus log y, because multiplication we convert into addition. And then we have division by z, which is going to be minus log z. And lastly, now we need to condense, go opposite direction. Log m by base b minus log n by base b and minus log u by base b. Okay, we have everywhere subtraction, which is going to be all division, right? Because division converted into subtraction and subtraction converted into division. So it's going to be equal log by base b. So log m minus log n, which is going to be m divided by n, and then another minus u, so it's going to be divided by u also. And that's it. Thank you for watching. This is practicing problem for group activity 3 and test 3, and I wish you good luck. Bye.